Hello everyone, welcome to this video. In this video, we shall be looking how to insert many numbers between two numbers such that the resulting numbers forms a GP, right? So we are given two numbers A and B. So we wanted to insert, we can insert in fact as many numbers as we like between them in order that the resulting sequence is a GP. But how can we do that? So let's have a look here. Suppose that we have inserted n numbers which are capital G1, capital G2, up to capital Gn, right? We have inserted these n numbers between the positive numbers A and B such that this A, G1, G2 up to Gn, B, they form a GP, right? So the first term here A1 would be A, the second term would be G1, the third term A3 would be G3, and so this Gn would be your n plus 1th term and this B would be your n plus 2th term, right? So here notice that B is the n plus 2th term which is known to us. Now according to the formula for nth term, we know this formula. Using this formula onto n plus 2th term, because it is given to be B, what do we have? We have a n plus 2 is equal to B. So a n plus 2 according to this formula would be a into r raised to power n plus 2 minus 1, which is r raised to power n plus 1. So we have a into r raised to power n plus 1 is equal to B. From here, can we determine the value of n? Yes, we can. How? We can shift this a to the right hand side, so it would be in division, right? And then we wanted to remove this power, so that means we would have to take its n plus 1th root. So how we can do that? We can take the power 1 by n plus 1 on both sides. So it would be B upon a raised to power 1 upon n plus 1. So you see in this case this n plus 1 and n plus 1 would cancel. So here on the left hand side we would have r raised to power 1 only, which is r. And on the right hand side we have B upon a raised to power 1 upon n plus 1. So this is the common ratio that we obtain, right? This is the formula that we are doing theoretically. For questions, you can directly calculate it. I'll show you in a moment how to solve questions. Okay, so this is the common ratio. Now once you know the common ratio, you can calculate all the terms A2, A3 and so on. Why? Because the standard form of GP, you know, it is AR square up to AR raised to power n, right? Then AR raised to power n plus 1. Now because you know the value of A, it is given to you. You also now know the value of this common ratio. You can very easily compare the terms with this standard GP, and you can have all the terms. G1 would be AR, right? So A is as such, the value of R we have substituted. The next term is G2, which is AR square. So A is as such, we have just substituted the value of R square, which is B upon A raised to power 2 upon n plus 1. Similarly, G3 would be AR cube, which would be A into the value of R we have substituted here and taken its power as 3. And in a similar manner, we can calculate all the terms here, right? So now let's use this procedure in order to calculate or insert many numbers between two given positive numbers such that the resulting numbers form a GP. So the question is, we need to insert 3 numbers between the number 1 and 256 so that the resulting sequence is a GP. So we wanted to fill in these 3 blanks. Right? How we can do that? We can consider the standard form of GP, which is AR square, AR cube, AR raised to power 4. So the first term here is A, which is 1, which is given to us, right? This 1 is given to us. So if you replace A is equal to 1 here, so our GP would be 1, R square, R cube, R raised to power 4 and so on. So this is our GP, right? Now next, in order to determine all the terms of GP, what do we require? We require to calculate the value of this R. So what is R? We know R is, we wanted to calculate this R. So here notice that we know the first term, we know the 5th term. right? So we have used this first term. What about this fifth term? We know the fifth term here is 256, and so that means by comparing with the standard GP, this r raised to power 4 is your 256, right? So you know the fifth term of the given AP is 256. So that means you may write 256 is equal to r raised to power 4. So you can solve for the value of r. So r comes out to be plus minus 4. Right, we are only taking the real root. So when you take the power 4, it would be plus or minus 4, because 4 raised to power 4 is 256 and minus 4 raised to power 4 is also 256. Okay, now once you have the value of common ratio r with you, then your GP would definitely be obtained by substituting the value of r into all of these terms. That is our GP. So here the first term is r, the second term when r is equal to plus 4, it would be plus 4, it would be 4 square, 4 cube, 4 raised to power 4. So the answer would be 1, 4, 16, 64 and 256. So that means we have inserted these three numbers 4, 16, 64 between the number 1 and 256 such that they are in GP. This is the case when r is equal to plus 4. What about minus 4? When r is minus 4, we have our terms as 1, minus 4 square, minus 4 cube, minus 4 raised to power 4. So that when you solve all of them, you would have 1, minus 4, 16, minus 64 and 256 as the digits, right? So that means here we have inserted three numbers between the number 1 and 256 such that the resulting sequence is a GP. So I hope you understood this procedure to calculate or to insert numbers between the given numbers such that the resulting sequence is a GP. Well, that is it for this video. Thank you for watching.